Hi YouTube, how are you? I hope you all guys are doing great. In this video, we are going to see solid principles. So we will be seeing all the five solid principles, why they are used, what they are, and how they help in designing these software entities like module, packages, or functions, whatnot. So the pattern that I want to follow is it's not about just telling you the definitions and uses of it, but instead what we can do is first we will see the definition, the book's definition, then we will see the actual uh, a extended version of the definition that can give you a better understanding. Then we will see whether it is really used or not. How many percentage of people are using this in startups or in the production code of startup or enterprise code base, or should we follow it strictly really? Whether these principles one by one are really valuable or not, whether they are really followed or not, and I will also show you code comparison that if some code is there which is not following SRP or OCP, and the same code when starts following SRP or OCP, how it looks like and what's the benefit of it. So that's all, and this is going to be a bit long video where I will be covering all the solid principles. So stick with me, and definitely if you uh, the code that I will be showing in this video will be available in this GitHub repo. I have already uploaded it in this solid principles repo, so I will add this link in the description box. You can go and check it out so that you can follow along with me. Okay, so the first principle that we are seeing is SRP. So here it is. I'm using Python. The simple reason behind using Python is because Python is the most easiest language after English. So this is a, a language which can be easily understood by anyone. So let's see. First is SRP, which name is single responsibility principle. By the name, it is much more clear that only a single responsibility should be given to the entities. Like either it is a class, module, or function, everyone should have only one reason to change. Okay, for example, here you can see in user service we had a create user. Inside create user we are doing lot of things. We are saving it to DB, we are doing some sending emails, then we are validating it, and we are also printing something, we are saving something and sending email and lots of things. So this is not a good code that is basically following SRP, because a class should be only having one reason to change. It should have a single responsibility to perform. Here you can see this is the improvised version where we have a class for validating user, we have a class for repository which will be saving to the database. We also have a class, just one class, and which is email service which will be sending the email. This user repository class is just saving to DB, and this user validator is just validating the code, validating the email. So this is what a code which follow SRP looks like. So if I can write it here, it is like um, improved version, I can say. I forgot to add it. So this is the improved version of the previous code only. So we have a user service, we added some in it, and then we are creating user, and it is validating, saving, and welcome data. This is at the runtime. But at the when we are we when previously when we were creating a user service, it was having lots of responsibility, saving to DB, sending email, validating. So this should not be like this. We should have a granular class, and now this class will be only changed when the validation method has been changed, the way of validating has been changed, or the way we are saving to the DB is changed. So that's why this is a single responsibility principle where a class or module or a function should have only one reason to change. Okay, nothing else. I think you all have been following lots of principle out of them, but it is a good practice to know um, something that exists, like okay, this is called SRP and I should follow it. And if you don't follow it and if you are new, always it's good to learn. Now, is SRP really used? Yes, but not perfectly. Like large or mature teams, like enterprise team like Google, Microsoft, you can say, try to enforce SRP because it makes code easier to maintain, test, or extend. But if you see startups or small teams, often violate SRP in early stages because speed is much more important than cleanliness. Because startups are known for their speed. Later, when code base grows, they pay the technical debt price and refactor. They have to again refactor it. So why not keep following from starting? Like in my experience, after doing some research, like I found that if you look at the production code in startups, maybe 40 to 50% of it follows SRP in a well manner, but in enterprise code base, maybe 70 to 80% follow SRP, but there are always exceptions. Now, should we follow it strictly? So, in ideal world, yes. Why not? That's why this exists, because it reduces bugs and makes future changes easier or safer. Reality, you can say sometimes you intentionally bend the SRP for speed or simplicity. If the feature is small and refactoring will cost more than the benefit, you might keep multiple responsibilities together for a while. Now, what is the rule of thumb for this? So, if the code will be touched often, follow SRP. If the code is rarely touched and it's very simple, don't over engineer and don't follow SRP here. Okay. So, if your code is touched more often, please follow SRP. Why SRP is valuable? Because it is easier to maintain, better for testing, lower risk when changing the code, and definitely reusability. So this is all about SRP. Let's see the second principle, which is OCP. So let's see. OCP is also known as open close principle. So like software entities like class, module, function should be open for extension but closed for modification. Okay, again I am repeating it. It should be open for extension but closed for modification. This is the important thing. Okay, like you should be able to add new features without touching the existing working code. So you have to think the whole idea whenever you are writing wherever you are creating a class or method, whatever. Instead just writing the code, please take some time, take some pause and think that how this class should be structured. Instead of adding the class directly, you can extend it through inheritance, composition, interface, whatnot. Okay, so let's see an example. It will give you a better idea. So we have a class called payment processor. I think it should be I should increase the font. Okay, sorry if it was not visible, but definitely this video is available in 4K, so you can zoom in. Okay, so here we have a payment processor. So currently we have a pay method, which is taking a payment type, and based on the payment type, it is doing something. Like if the payment type is credit card, processing credit card payment. If the payment type is PayPal, then processing PayPal payment. But let's suppose in future you got a new payment type. Let's suppose it's UPI. Then again you have to come back and improve this class. So this class is not, its class is open, not even open for extension. You can say it is open for extension, but it is not closed for modification. You every time a new method will come, new payment type will come, you have to come and again add a if elif. Okay, definitely factory patterns can help here, but keeping it aside, okay. Now let's see what is the improved version of it. So let's suppose we created a payment method, which is an abstract method. So it is just a contract, but abstract method is just a contract, okay. So that anyone who will extend it, they will just have to follow the contract. That definitely they have to um, write the pay method. They have to override the pay method. Now let's suppose we have a credit card payment. So we will extend this payment method and we will implement the same method, pay. So processing credit card payment. Now we have a PayPal payment. So again we will extend this payment method and we will do it. So this payment method is, you can say that it is open for extension, like we can extend it, but close for modification. No need to go and change this method. Okay, if you want, if you have a new payment method as UPI, so simply you, what you can do is you can create a class here, class UPI payment, and you can extend payment method and again implement the pay. So print processing UPI payment, and basically we have a payment processor basically which takes a payment method and it will implement this pay method. So if you just run it, you will get processing credit card payment, because we are passing credit card method. If I do it PayPal, it will give us PayPal method. So see how the big difference is. Even this code will work, this will also work. But think of future always. Always, if you want to become a good coder, or if you want to make your code more scalable, extensible, then definitely we should think about the future. What would happen if a new payment method comes into the picture? Then definitely this type of implementation is really, really important. So always remember your classes should be open for extension, but closed for modification. Okay, now let's see why does it matter? Because changing existing well-tested code can introduce new bugs. Okay, in place um, you didn't even expect you will face some bugs. So it is always a good code that if it works, don't touch it. Okay, if you have existing code and it is well tested, so don't try to modify it. But by extending instead of modifying it, you reduce the risk of breaking things. It makes easier to add features in future without retesting everything from scratch. Is OCP really followed? Yes, but in different level of strictness. Large scale, long lived projects like banking, enterprise app, libraries, frameworks follow it very, very closely. Even in everywhere you see the examples of bank only in case of inheritance and all. Fast moving startup projects may ignore it at early to ship quickly because they have the pressure to ship it quickly. Okay, but they regret it later when adding new features becomes risky. Because let's suppose there is a coder who wrote this code in startup, but in future they thought of adding 4 to 5 more payment type gradually, then it will be a pain for them. So roughly, if I can tell you stats that well architect enterprise code like 70 to 80% they follow OCP, but startups, small projects like 30 to 50% follow OCP. Like more conditional logic is more common because this logic feels more intuitive, and this comes by practice or by your senior guidance or just by having more thoughtful process. You have to spend some time to it. If someone is assigning some 1 or 2 story points to your Jira tickets, and I don't think you will able to have that time to think about it. That's why small projects, fast moving startup projects gradually end up doing this things. Okay, should we follow it strictly? Yeah, if you expect frequent feature changes or expansion, follow OCP. It will save your pain later. If the feature is on off and won't involve, don't over engineer. Never over engineer anything. Okay, just think whether I can apply SRP, either I can use OCP or not. Okay, sometimes even simple if else also work. Okay, so that's it. What is the rule of thumb? So first is stable, widely used component should be strictly following OCP. Internal short-lived code is like you can have provide some room for flexibility over perfection. Okay, so if stable and widely used components you want, then definitely you should follow strict OCP. And I've also shown you an example what's the benefit of it. Okay, yeah, this I missed. So we have to add a new payment method, so class UPI payment, and you can add something, and when we will call it, definitely we will get a UPI payment. You don't have to touch a lot of code. Okay, and definitely this class are all in a new file, in a new module, so you don't have to even touch the previous code. And the less you will touch the old working code, the better chances of your success. Okay. Now coming to LSP. So let me open this notebook. So LSP is Liskov substitution principle. I don't know what Liskov means. Okay. So what actually, maybe it's name of the engineers or something. Liskov substitution principle is if S is a subtype of T, then objects of the type T should be replaceable with object of type S without changing the correctness of the program. I know it sounds confusing. So let me make it a bit simpler. If a class inherits from another, it must behave like parent, not breaking the expectations. Like, okay, anywhere your code expects the parent class, it should work fine with the child class. Okay, let me give you an example. So this is a code which is not following LSP. So we have a payment gateway, which is our base interface, which is having an abstract method as charge because this is a contract. Now we have Stripe payment gateway. So this gateway is inheriting the payment gateway, and it is definitely this is working fine. So we have a charge method. We are overriding it. Now we have cash on delivery payment gateway, and it is also inheriting this payment gateway. But now you can say um, whenever we are extending this charge, it is saying it is raising an exception that cash on delivery cannot process online payments because this charge was for only online payments. So when someone will do something like this, we have a process payment which is a client level code. It is taking some gateway, some amount, and when we are running it, so we have created two objects: Stripe payment gateway and cash on delivery payment gateway. Now, if we try to run it, okay, so what we will get? Okay, let's just check it once. Actually, I've already done it. So processing payment of $100, then Stripe charging $100 online. Processing payment of 100. This is for, I can say, for cash on delivery payment gateway. Now we are getting an error. Cash on delivery cannot process online payments. Why? Because cash on delivery payment gateway is signing a contract with payment gateway, and payment gateway is having a method charge, so that should be always implemented. But cash on delivery payment doesn't need charge. Okay, there can be another method because it is on, you have to give the cash in hand, because charge may have some online things. Okay, the transaction can be online, so that's why we had a charge. So this class is not following this ls, what we say, lsp, because the a class, this is a class which is inheriting from another class which is payment gateway. It is not behaving like a parent. Okay, parent wants to have a charge method, but cash on delivery payment gateway doesn't need a charge method. It can have another method. So that's why it is breaking here. It is not following lsp. How we can make it proper? So instead of having a payment gateway, we can have an online payment gateway. Basically we will have a interface which is payment gateway. Now we will have online payment gateway, and which is having a charge method. Again, both are also interfaces. Okay, then we have a offline payment gateway. Again, this will be having a collect cash, because online payment gateway can basically follow online transactions, but offline payment gateway cannot follow online transactions, so they can have a method as collect cash. Now Stripe payment gateway can take, can inherit or can extend online payment gateway, but cash on delivery can extend offline payment gateway. So this problem is solved now. Okay, so it can extend or override charge. This can override collect cash. So we can have different two different method: process online payment, process offline payment, and it will take two different gateways. Like this is online payment gateway, this can take offline payment gateway, and also you can merge it because gateway can be of any type. It can be of also payment gateway type. Okay, just for sake I have written this code. Okay, just for explanation purpose. So now we have Stripe and COD, and we can have like this: processing online payment Stripe, processing offline payment COD. So both will works fine. So that's why the principle is, whenever a class is being inheriting with from some class, it should behave as a parent. Okay, if parent is following something, then definitely cash on delivery should also follow the same parent method as Stripe payment gateway is following. Okay, so this is the thing. Okay, I think you have understood, and anytime if you have any doubt, please let me know in the comment section. Okay, so do we follow LSP in industry? Yes. Well, architect libraries, frameworks respect LSP because they must maintain backward compatibility. In real world application code, violation happen more than you think, especially when developers inherit class just to reuse the code without thinking about the behavioral expectations. Industry the industry gut feel is like, maybe around 80 to 90% follows LSP strictly. I'm talking about the frameworks and library codes, but every day in business app code, I don't think so. Even 50-60% would be even following this, and definitely they are just using the misuse. They are just misusing the inheritance. Should we follow it strictly? Yes, more than SRP and even OCP, because violating LSP can cause hidden bugs that only show at the runtime. Okay, because this type of code initially looks correct, but when you fall to such situation, uh, it's like you catch the bug on the runtime. Definitely, everything is not in one place, so it is very scattered, a huge project. So catching this type of bugs are sometimes a bit harder if you don't follow LSP. Also, it makes polymorphism unsafe. The whole point of inheritance get destroyed because of this. A rule of thumb: if your subclass can't fully honor the contract of the base class, don't inherit it. Use composition in it instead. Means just break it, because here you can see this cash delivery payment gateway was not completely respecting this contract of payment gateway. So we just composed it, and we have made two different payment gateways, online and offline. Okay. So this was about LSP. Now let's come to second last, which is ISP. Okay, so let's go to ISP and let's see what actually ISP is. ISP, the full form of ISP is interface segregation principle. No client should be forced to depend on methods it does not use. Okay, like does not make a interface that has all possible methods. Instead, split into smaller, more focused interface so each client only get what it's need. Okay, so here you can see like payment gateway was a bad fatty interface, like it was containing a charge as well as collect cash. Now if we have Stripe payment gateway, uh, as this Stripe payment gateway is signing a contract with payment gateway, so it has to implement charge and collect cash. But in Stripe, we know it's for online payment. So why the collect cash is even important? So it will we have to raise a not implemented error. Same with cash on delivery. If we are signing a contract with the payment gateway, then there is no need of charge because there is no need of online payment. Just maybe in cash on delivery you also need online payment. But as of now, I'm not thinking about that. Just collect cash is the important thing in COD. Okay, so this is the thing that we have made a God interface that has all possible methods. Now, even some class or methods that don't need this type of method, they have to also use it. Okay, so what can be an improved version? I think you might have already thought when I was explaining. So we will make an online payment gateway which will just containing charge. Offline payment gateway which is just having collect cash. So now Stripe will take the online payment gateway and it will override charge method. Cash on delivery will take offline payment gateway and it will override collect cash method. And definitely we will just have two different methods which will take online or offline gateway, and maybe we can also merge this. So we have two objects and boom. So it will give us this and this. Okay. Because this is not a good way to raise some errors. Okay. So instead, this seems bad engineering. This is the good engineering. Okay. So, how industry uses it, like front-end UI component. Instead of one UI component with render, on-click, drag, on-drops, they're split it into smaller interface like clickable, draggable kind of. Microservices is a good example. API should expose only to the operations relevant to a client, not to the entire system capabilities. You might have also seen cloud SDKs like Azure, AWS, GCP. They split the services into small client interface like S3 client, EC2 client, not rather than having a complete God client. Okay, so this is simple. Okay, I think you should follow it. ISP is also a really good thing, and it's much more intuitive to see. Then we have dip. So let me open the dip once. Okay. So dip is dependency inversion principle. So like high level modules should not depend upon low level modules. Both should depend on abstraction. Abstraction should not depend on details. Details should depend upon abstraction. Okay. So let me explain you with easier term. Okay. If you want to see the definition here, it is the definition. So high level module, like suppose you have your core business logic like payment service. Low level module like a specific implementation like Stripe payment gateway, PayPal payment gateway. Instead of high level code directly depending upon the low level implementation, both should rely on a common interface or abstract class. Okay, let me explain you. Okay, so see here you can see this code which is the violating code. So we have a Stripe payment gateway which is having charge. Then we have a payment service. It is taking we have creating an object as self.payment gateway of Stripe payment gateway. Then we have process order. We are taking some amount and then we are just doing self.payment gateway dot charge. So we are calling this charge method and we are just service dot process order. If I just run it, it's working. Stripe changing 100 online. So if you switch from Stripe to PayPal, you must change the payment service code. Okay, because see, here it is written like Stripe payment gateway is there, Stripe is there. If you have to implement, if you have to add your, let's suppose instead of Stripe, now you have to use PayPal, then you have to change a lot of things here. Okay, so if there is a good code, then you should not be changing the payment service directly. The code should be so flexible that you can switch to any kind of payment gateway. You can't easily test payment service without hitting this stripe. So if you want to test payment service, definitely you have to hit this stripe. Okay, either you can mock, but you have to hit this stripe. So it it's not a good practice. It violates the dip like high level business logic, which is the payment service. It depending upon this lower level, it is locked on the lower level detail, which is stripe payment gateway. Instead, what can be a cleaner version? So this is the cleaner version when we where we have payment gateway which is having a method as charge. Now this is a low level implementation where we have Stripe payment gateway, which is in a extending payment gateway and having a charge method. Then we are having PayPal payment gateway, which is again inheriting payment gateway, and then we have a payment service. See, now this payment gateway payment service can accept any kind of payment gateway. Okay, it can be Stripe, it can be anything. Okay, it can be PayPal, it can be anything. Just you have to just you don't have to touch the payment interface. It should just have a charge method. Let's suppose we have a UPI payment gateway. It will extend payment gateway, and just we have to go through the contract that okay, we have to implement a charge function, and simply you can do this. Okay, so here you can see payment service, which is this one, works with any kind of payment gateway that follows this payment gateway interface. Simple. Adding new gateways requires no change to payment service. Simply you can create a class or a module. Okay, it is easy to mock payment gateway in unit test. Okay, it's very easy to mock the payment gateway. Okay, and it also follows OCP, and basically it follows OCP also, because I think you might be thinking this is similar kind of open close principle, so that here also we had credit card payment, PayPal payment. This is the same thing. Okay, so this is basically open for extension, closed for modification. Okay, so this is all about dip. So basically, if I want to summarize this dip into a nutshell, instead of business logic saying I will use Stripe, it should say I will use whatever payment gateway someone gives me, as long as it goes through a contract which is having charge. So this was the case, because that's why we create interface. So we sign a contract that okay, this class is having a contract with payment gateway, that definitely always I will implement this method till I die. So instead this method, previously this method was clearly saying that I will use Stripe, but now this method, this payment service is saying no matter, bring me any payment gateway, I will work on it. So that's the thing. This is the power of dip. Okay, so I have also created a project for you. It's just a basic project. Okay, so which can show the use of I can say the summary of all these principles. So let's go to interfaces. So if you see interfaces here, so we have an interface as payment gateway, which is online payment gateway, which is in a extending payment gateway, and also this payment gateway. So can you tell me which kind of principle it is following? Definitely it is ISP and LSP. Okay, because if you see for the ISP means no client should force to depend upon the methods it does not use. So if I go to interface, so this is having a charge, this is having a collect cache. So it's not like payment gateway should always be having charge and collect cache. Okay, and same for LSP. Okay, I think now you can already identify it. So basically we have already seen LSP, which was um, like if a class inherits from another class, it must behave like a parent. So this is also where LSP is also getting followed. Similarly, if I move to this project and if we go further in services, so here we have a parent payment validator which is validating some amount. We have a notification service which is sending some receipt. Let me just make it a bit smaller. Okay, then we have a payment service which is process online payment and offline payment. It's supporting both. So basically this one is SRP, and also it is because separate we have separate validation services. We have some service just for sending something, and it is also following dip because payment service depends upon abstraction. So whatever payment method we have, it depends upon abstraction. That okay, if we are taking gateway which is online payment gateway, just implement charge. If you are having offline payment gateway, just do collect cash. Okay, just extend collect cash. Then we have some gateways. So we have Stripe payment gateway, PayPal payment gateway, cash on delivery payment gateway, which basically is OCP because it is easily extensible payment gateways. So because it is as we know, Stripe payment is for online. So online payment gateway is open for extension but closed for modification. Similarly, this is offline payment gateway, cash on delivery, again following OCP. So that's simple code. Okay, definitely this all things are available in GitHub. You can just go and take a look at it if you want to follow with me along. So basically we are doing just processing online payment and offline payment. So if I just make it a bit bigger, so here you can see Stripe, and we have also sent some notification.
PayPal, then we have sent some notification, collecting cash, and then we have sent some notification. I don't want to go line by line because it's very simple to understand because we have validated and notified that only we have two services. Okay, so that's it. In this, we have seen lots of things. Okay, majorly on solid principles, and definitely these all things will be available here. Now, I think I should summarize all these things. So let me summarize it. For S, it is single responsibility principle. So one class, one reason to change. Then we have O, which is OCP. OCP means open close principle. Okay, so this one. So extend without modifying the existing tested code. Because if someone is already tested that code, don't touch it. Then LSP, list of substitution principle. Subtypes should be usable anywhere. So their base type, as their base type is expected. I is interface segregation principle. Don't force the class to implement things that they don't need. Okay, the way we saw for online and offline. Then D is dependency inversion principle. So it depends upon abstraction, not the concrete functions. Okay, so that's it. And if you keep these things in mind, your future will be, or your future self and your teammates will thank you, like when maintaining and extending such code. Okay, you can also do it during making it like if else later. But if you keep it in mind, it is also good for your interviews. It is good for your understanding. And don't worry, like in real world project, nobody follow a solid 100% perfectly. But knowing this helps to you to make much better design decisions. Okay, at some point you will also see that usage of all these things are really really important. So that's it. I hope you like this video, and if you have any concern, anything, please let me know in the comment section. I will definitely try to help you. And if you like this, please hit the subscribe button and like this video. And there are lots of things are coming in this channel regarding architecture, system design. So please follow along it. Thank you. Bye bye. Have a great day.